Hello, my name is Noah Geiger, and this is my Physics 2 Lab 1 charge tape experiment. Okay, so some of our goals were we wanted to determine the reaction between the charged tapes and different items. We also wanted to estimate how many electrons the tape lost whenever we did the process of charging them. That's when we ripped them up from each other, and that caused them to lose electrons. And we're going to do that by applying Coulomb's law. The result of the experiment was the positively charged tapes repelled each other when they were near, so when I put them together, uh, they moved against one another. The electric charge of a single piece of tape was found to be approximately 1.25 times 10 to the negative eighth coulombs, and it was found that the tape efficiency was 7.3 to the 10th, or times 10 to the 10th. Some relevant concepts is two major things. We're going to use Coulomb's law. Coulomb's law is Coulomb's constant. Q1 is the first point charge. Q2 is the second point charge, and R is the distance between the charges. Newton's second law, F equals mass times acceleration. And we're going to be using these two to determine the different charges between the two tapes. And yeah. So our model consists of two pieces of tapes that were charged at a distance away from each other. You can see here's all our initial conditions, the tape length, the tape width, the tape mass. Basically, we put them on top of each other and charge so that we can see their reaction. Observation, the experiment, whenever the tape was put near a negatively charged item like a plastic pen, it go towards the pen. And then whenever it was by a positively charged object, just as my hand or even the other piece of tape, it repelled. Just kind of showing that it did indeed lose electrons in the process. Coding. So we're going to hop over to my code over here. So this was the initial code to determine uh, the uh, the charge of one piece of tape. So as you can see, we wrote kind of the function, had the mass, included gravity, distance, all that stuff. When it's programmed, this right here, we're going to get our charge on one piece of tape. We can then go to our second piece of code here. I believe this was provided to us. And we have our things that we edit here. So the two things that we're going to be editing is our mass, which we were able to calculate previously. And the second thing we're going to do is the charge, which we found from the other code. Uh, the code just, we inputted our variables and it gave us what we needed. So we run this and we see that uh, what we should consider with all the tape is we need to consider them as a line of point charges, just because it'd be really hard to somehow figure out how to do all the tape look through charge. And with our formulas and with our model, we were able to find the magnitude of electric forces to be 1.8 times 10 to the negative fifth, and our gravitational force to be 1.6 times 10 to the negative fourth. Um, yep. So as I said, these are numbers. We calculated the number of atoms in the sticky note is 7.3 times 10 to the 10th. The electrons lost were approximately 3.8 times 10 to the 17th. Some possible discrepancies that we found that could have been there with the data is, for one, air. Air can definitely disrupt the electron transfer. It could also mess up, what repels, what doesn't. But probably the more important thing is hands. Hands, you know, they'll transfer the electrons from my hands to the tape, and that it gets some discrepancies. One big assumption that we're doing is we're treating the two pieces of tape like point charges, like I showed in the model, with just a bunch of little point charges. Again, we have to do that because we don't really know a way to treat the tape as just tape. So what if the electrons were positively charged and protons were negatively charged? Nothing would really happen because the stuff with their opposites attract and likes repel. So even if they did change charges, even though I think that caused like a black hole or something, uh, the concept should remain the same. Just because the concept of opposites attracts likes repel. So why is it important to handle tape as little possible? Like I said before, the more you hold onto the tape, the longer, the more chance electrons from your hands could pass into the tape. I mean, this is very a small experiment, and yeah, so very small things like that could interfere with it. But yeah, that's all I have for you. Thank you for watching and have a wonderful day.